When hurricanes form and move toward land, millions of people rely on predictive computer models developed at a NOAA laboratory in Plainsboro. And for the researchers, each hurricane season is a chance to test, evaluate, and improve the models. Science and technology correspondent Patrick Regan reports.
When the National Weather Service issues predictions about tropical storms and hurricanes, these rest on expert interpretation of what a handful of computer programs project. These mathematical models try to capture the complex physics of ocean and atmosphere in equations that a supercomputer can solve to predict where a storm will go, how intense it will be, and how much rain it will drop. One of the leading models originates here at the Geophysical Fluid Dynamics Laboratory, or GFDL.
For just Gustav, at 3 days, our track errors were about 33% less than our long-term average. And at 5 days, they're about 25% less. One area that our model did real well on was predicting the speed at which the storm was going to move.
In addition to consistently nailing Gustav's track, Tim Marchok says the GFDL model gave the earliest and most accurate prediction of its landfall. It didn't do so well on Gustav's intensity. This is revealing, Morris Bender says, because recent improvements in representing the so-called loop current and related phenomena in the Gulf of Mexico may have caused the model to overestimate intensity.
We look at our successes and failures after the season finishes, and that's a good test bed for evaluating some of the future improvements of the model.
They say forecasting precipitation, such as what our region might expect from the storm named Hannah, depends on predicting the track exactly.
We're still about a day and a half out for that storm moving through this area, and so there's a lot of variability in that track.
Patrick Regan, NJN News, Plainsboro.